Sir.
My voice is audible, sir.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Clear, sir.
Okay. So in this session, I am going to give some glimpses in the trends in real-time control of power systems, especially SCADA communications and protocols, and how it is linked with the substations, master stations. So in those aspects, I'm going to discuss in these sessions. So usually this is the typical SCADA network we can see. So first lower levels, layers, there will be field type of devices or sensors will be there, and it will be connected to some of the communications will be connected, and from that like some substations, through that again through the RTU or IED, and from that again to SCADA, like that it is connected, and in the control centers or master stations it will be displayed. So those aspects is a typical supervisory control and data acquisition systems. So these SCADA for electrical power industry, if you see, there will be SCADA for generation at the generation point, or SCADA for transmission at that point, like SCADA for distribution. So in that way, energy management systems will be there throughout from the generation to distribution. Even now with the smart grid, everything smart technologies, even home automation like that also has emerged a lot. So even industrial consumers, their own plants, their own SCADA systems they will be using, or very big high-rise buildings. They are using SCADA systems for their whole building automation and all the process and monitoring control aspects, and they are doing. So like that, different applications we can see these SCADA apply for different aspects. So particularly, we will be focusing the SCADA for our power applications. So these are typical SCADA for power distribution network. So incoming feeders from the devices, from the CBs, all the data will be collected and monitored at the master stations. So in that way, all these parameters, if you could see, everything will be like data aspects. They will be taken into that, and particular servers will be there where those particular data and all will be stored. So and it will be processed for the monitoring, control, protection, like. So these are typical measurement elements, sensors, how they are converting into digital data and passing into communication channels, and again connected to master station. This overview, overall picture looks. So even if you could see the components of SCADA systems, like field equipments, like field devices, CTs, PTs, data, or switches data, RCBs data, everything will be related to field data, and it will be passed to RTUs. Nowadays, IEDs, intelligent electronic devices, also they are using like multifunctional monitoring as well as control, as well as protection aspect. They are using. Is
garbage stuff.
So here RTU holds the main role, and in monitoring, controlling the devices, like that. So in the SCADA system, communication system, master stations will be there. Human mission interface like displays or the SCADA master station will be there. has a whole bus systems, everything will be monitored, and wherever the required control or protection can be also will be done. So these are the typical SCADA applications we can see. So from the substation automation aspects, generation aspect, distribution aspect, transmission aspects, we can see these SCADA applications. If you could see in automatic generation control, equipment and computer programs implementing closed loop feedback control of frequency, net interchange, we can do with this SCADA. Economic dispatch calculations, computation, everything can be done, and so that it will minimizes the cost. In that way also we can use economic dispatch calculations, interchange transaction schedulings, transaction evaluations, and also unit commitment, hourly startup and loading schedules. That minimizes the production cost, and also short-term load for forecasting can be used. Hydrothermal coordinations, like scheduling of power from all available hydro generations, so that they will try to minimize the cost. So transmission SCADA applications also, like network configuration, topology. So there from the transmissions, status of circuit breakers, measurements, all the things can be done automatically. State estimation, so also can be done through the here, whichever the data, and from that, suppose CTs or PTs measurements, suppose some error is there, so again that can be done with the state estimation, and so analyzed properly. So in that way also we can use these applications. Contingency analysis we can do, transient stability aspects and all. Even three-phase balance of power flow, complete voltage angle, magnitude, information, everything we can get. Even now, intelligent electronic devices with phasor measurement aspects they are using. So synchro phasor through GPS, time stamping, everything can be done parallelly, simultaneously. That features and all nowadays it is added in the devices. So optimal power flow. So in the distribution automation, there are different applications we can find. Fault identification, isolation, network load management can be done. Active reactive power control, power factor control, three-phase unbalanced power flow, like that. Some different from different layers we can use based on the protocols. You can use these features, everything. So mainly the main advantage is supervisory control and data acquisition. If you could see, less severe contingencies and outages can be addressed. Lower optimized cost can be done with these automations. Faster restoration of power, even if there is any breakdown or a blackout. If there is anything, restoration, everything can be done very fastly. And also active and reactive power managements also can be done appropriate time. Also reduce maintenance cost. Like nowadays we are going towards the time based to the condition based maintenance, like using the sensors, everything. As this workshop also the main motive is of IoT and cyber security. So those condition based maintenance is nowadays well taken up, where with the severe problem itself, you are identifying the problem. When compared to time based, what happens at particular time we are seeing sometimes minor thing may come to major problem. So if you use the sensor network through the IoT technology and all, very at the initial level itself, minor problem itself, we can able to identify using the sensors and the network, everything. So in that way, even we can use different diagnostics techniques from that, like a neural network, artificial intelligence, MI, where we can analyze the problems, because you need very high sensitivity devices. So minor problem means their sensors should be having high sensitivity. So where in the environment where you are having noise environment, everything. So there again, you require very high denoising techniques and all. You have to apply signal processing techniques. You have to apply again. This AI and ML will very helpful in classification, and as well as with the optimization techniques, we can further we can provide more accuracy, localizations like that. We can better can be done from the condition-based maintenance. So that is where these IoT everything very useful for that. So reduced human influence and errors also, in that way when we are doing all these measurements and all at time to time, with good communication aspects, when you are receiving the data and taking appropriate actions. So those things, the advantages we are getting with this SCADA, and nowadays with technological advances in communication aspects, like that, still we are able to do facing so many challenges and solving the problems with this. So like that, we can do the sequence of events, recordings, everything. So time stamping. So how the whenever the any problem, any fault occurs, from that point onwards, there is a change from the normal to there is a change when fault occurred. So that aspect also can be analyzed properly with these time stamping, everything, at what time it has occurred, what type of devices were there, and in what way the particular fault is coming to picture. So all this can be analyzed very properly with these sequence of events, recording everything. So in that way, it will be very helpful to take appropriate actions, load patterns, everything we can get. We can get power quality improvements, so we can monitor harmonics, voltage sags, as well as unbalances, and we can do corrective measurements, like switching of capacitor banks appropriately. So wherever sudden voltage dip is occurred, so you have to switch the capacitor banks and all. So in that way, it will be helpful. Very faster, appropriate actions can be taken. In that way, quality of the power supply can be improved at the consumer point, like that. So if you could try to analyze from the lower layer onwards, like where we have various field devices from the substation, and we are trying to get these data from these field devices, switches, isolators, CTs, PTs, for voltage, current, power. All the measurements should be monitored, and also appropriate control actions will be taken. So in that way, we have various substations there, generating substations, bulk power substations, or grid substations, distribution substations, like that. So where, if you could see, particularly transmission substations, all these type of equipments, whichever is there, we are trying to get the status of that, and try to wherever the criticality is there, and that particular parameter we of the data we will try to use, and appropriate actions will be taken, like transformers, with and without tap changers, station buses, insulators, current transformers, potential transformers, EBs, isolators, reactors, capacitors, especially IEDs, which acts as a intelligent electronic devices, like they are multifunctional relays, nowadays from RTU for the protection features also included in these IEDs, substation batteries for auxiliary power supply, everything, wave traps, especially for power line carrier communications we are using. So distribution substations, if you could see in the substations, so these are all what we have discussed. So these are typical substations where we can find all the switchgear protection equipments, and from that all the data will go to the control center there, the substation panels, and appropriately it can be seen, monitored, everything, and appropriate actions also will be taken, and protection also will be done. So all these aspects you can see here in the outside power transformers. Even in the power transformers nowadays, dissolved gas analyzers are also coming into that. So where uh, appropriately you can see the how the based on the severity of the problems, the content of gas dissolved also can be taken. Even with the sensors and all, the data can be taken and appropriate actions also can be taken. Like that, critical, non-critical, all the data can be acquired, whichever important, whichever critical, and should be send appropriate communications. So in which the SCADA from the master stations will be received very fast, and the appropriate actions will also will be taking into that considerations. These are the isolators where all the data will be taken. So whichever important it should be desired, should be taken into consideration, and even sometimes if there is any change of that state, that also will be taken into consideration. Otherwise, they won't consider it. Like that. Data aspects also they are try to optimize how the data has to be taken. These are all the important things where the processing of data and the storing the data is coming in importance. So you can see disconnectors interlocked with the associated circuit breaker. Those things and all, the status, everything can be monitored. So these are the typical control panel you can see in the control of the operation of whole, whatever you are seeing outside substation equipments, everything will comes to here, and it will be monitored as well as control, and even protection aspects and all will be done appropriate timings like that. So some relay panels you can see here. Lightning arresters, current transformers. So where we are trying to measure the current and the parameters we are using. Potential transformers. So bus bars and as well as capacitor banks. Everything monitoring will be done, and appropriate energizing all will be done here. So these are the battery chargers. The typical substation, if you could see. So if you could see these power line carrier equipment. So usually power line communications and all we can use like voice communications, telemetry, telecontrol, SCADA purpose, like that different purposes we are using this power line carrier communication. So usually these carrier current usually in the frequency range like 30 to 500 kilohertz for the communication between the two substations. If you want through the transmission line itself, we can do this at higher frequencies. So in that way, you will be getting the information, everything between the substations and all. Through the transmission line, you are trying to get these informations. which are of 30 to 500 kilohertz frequencies. So in that way, in the power lines, these high frequency signals, carrier communication, everything will be transmitted through the power lines. So even you can see different components here in these power line carrier equipment. Coupling capacitor, you can see. So usually these coupling capacitors, it will offer low reactance to carrier frequency and high reactance to power frequency, so that those information will be only will be allowed into that. So in that way, the carrier frequency signals will be allowed into the carrier equipment, and it will won't allow the, because it offers the high reactance, it won't allow the power frequency 50 Hz. So usually these line trap units, you can see between the bus bar and the coupling capacitor to the line. So usually for remote measuring signals, remote control signals, as well as protection signals, telephone conversations, like that we will be using this. So usually these line traps will be using to prevent high frequency signals going towards the undesired directions, like that we will be using these line traps. So mainly, if you could see here, uh, main coil is there, tuning unit will be there, over voltage arrestor will be there in that. So basically this main coil carries the full line current, and it is designed to carry normal current continuously with the temperature rise within the limits also. And usually these coils made of such a way that it will carry a short circuit current for specified duration also, like some 1 second, like that capability will be provided. So in that way, it will have low self capacitance, and in higher frequency applications, you can use very well. This tuning unit, if you could see, uh, these are mounted inside the main coil on the tension rods. So these designed in single wave, double wave, wideband also. These are tuning units. So usually located inside the main coil, and protects the tuning unit from the even impulse voltage also. These over voltage arresters and all. So everything is as per standards. These line trap units and everything, they have to use as per standards, some IEC standards they will be using, like some inductance aspect, normal current aspect, capability, short time current aspects, like that also there will be standards will be there in that. So this is the whole scheme of power line carrier, where from the substation to substation, how they are transmitting and receiving these carrier currents, and how it is going to. So these are typical scheme of the power line carrier. So you can see here in the oscillators. So these carrier frequencies will be generated. So this oscillator will be tuned to particular frequency for that particular application. So this is the receiver unit, where you can see the high frequency signals arriving from the wherever from other substations received by this receiver, and it will be feeds into relay unit. So in that way, the receiving unit will consist attenuator, band pass filter, matching transformer will be there. Any signals which are caused by, suppose some short circuits will be there, radio interference will be there, and also if there is any mal operation due to noise, so those things and all will be taken care in this receiver unit. So so in that way it will be useful. Usually some modulation of this high frequency signal, everything will be done in that. So in that way, we are using for the carrier communication, carrier protecting relaying, carrier telemetry. Those aspects and all we can use very well, those applications of this power line carrier. So you can see the substation operators on a single line diagram. So these are the protective zones, necessary clearances needed for the in the zone of these substations. So phase to ground clearance, phase to phase clearances. So in the typical substations from the various feeders, so how it will be typically, it will be seen like bus bar 1, bus bar 2 will be there. You can see all the CTs, appropriate location, CBs, PTs. So you can see while from the feeders entering into the substations, you can see wave traps there, earth switches in the lines, circuit breakers, current transformers, isolators, appropriate locations you can see. So this is a current transformer where we are trying to get the from high current to low current transform. So these are, you can see these current transformer designs. So typical current transformer. These are the capacitive voltage transformers. So even nowadays, there is a more advances in the instrument transformers also, like optical instrument transformers. So they are using for accuracy, linearity, high dynamic range, efficient installations. So these optical are finding nowadays in the applications also, like line protection, transmission distribution, improving the accuracy of line fault location, generator protections, transformer protections, bus protections, excitation measurements, along with the phasor measurement units will be used, and also under voltage load sheddings, measurement and protection for reactive devices, shunt and series capacitors. So it will find applications. So these are the conventional cities with optical readouts. So in that way, in the current transformer aspect, CT aspects also, there are more advances, you can see electrical to optical conversion unit from the current transformer to here. So with the conversion city with optical readout, this is one type of device. So you can see optical current transformer or optical voltage transformers in this. So the magnetic concentrator with optical measurements. So in that way, we can use the IoTs for these measurements, and we can do mm, appropriate actions also. Optical path. So these bulk optics, they are using some technology. So optical voltage measurements. So optical voltage transformers. So this is the electro-optic voltage transformers they are using nowadays. So you can see how they are measuring through the optical fibers. So analog processing, digital to analog converter again. Analog output voltage they are getting into that. So these are typical power line carrier equipments, how they are connected. So in the SCADA systems, if you could see, basically analog data will be acquired from the transformers, station buses via like current and voltage transducers, and it is processed in the control room, converted into digital, and further will be done. And status data also we are acquiring, like circuit breaker status, opening and closing of the status of the circuit breakers, isolators, shunt and series compensation devices, on or off positions, conveyed to the master station. These are all status data, digital data, analog data, those CTs and PTs. Environmental data, temperature, pressure, humidity, weather conditions, all also will be passed on to the control center. So these are the various types of data and signals in the power system. So basically analog and digital data, pulse data also acquired, like for the energy meter data and all, accumulation functions, pulse data, like that also can be used. So these analog signals, like voltage transformers, which are step down voltages to the level of 110 voltage, and there again voltage transducers converts this into the 4 to milliampere standards type of devices will be transducers will be used for that purpose. In that way, it will be measured. So why we are using this from the analog signals, voltage transformers? Even we are trying to convert into like using the transducers to the current output is like we can whatever the we can even transmit over a long distance also without drops and all. So in that way, also less prone to the distortion from the interference. So in those aspects and all, the current output will be preferred uh, uh, from the transducers rather than voltage. So these are 4 to 20 milliampere current loop transducers using. So usually, so why they are in the transducer 4 to 20 milliamperes is zero input corresponds to 4 milliamperes. So it is not the 0 amperes, but uh, zero input corresponds to 4 milliamperes. So if there is any broken wire, it will show zero output. So in that way, we can decide on that. So some malfunction happened like that. If it is measuring 4 million, so it is a 0. So if it is broken, so it will show 0 output. So in that way, it will be seen properly. In that way, 4 milliamperes to 20 milliamperes current loop we are using. So these are the uh, this 4 to 20 milliampere current loop output. So typically, we can see current loop like this 4 to 20 milliamp transducers. So even DAC devices, data acquisition devices, also we can use for this. So these are the various aspects in measurements of the current loop system, how we can use the transducers and how to acquire the data, and in what way we can pass it to further stages. So common method of preventing ground loops, if there is anything, we can use the particular techniques to avoid that. So likewise, we can use and get the correct measurements by following those designs in the sensors. So from sensors, transducers, which are converting into 4 to 20 milliamperes, again signal condition circuits we are using. Again from the digital, we are converting ADCs like that. So digital signals, switch positions, isolators, circuit breaker positions in the power systems, we can get these status and all by means of digital signals, and automation systems directly will be accessed. So here via interposing relays, the digital signals coming to the system for physical isolation also. So this you can see digital signals how they are coming. So if there is any movement of breaker contacts, you see, so open and close contacts, that status and all we can get. So these interposing relays initiate actions in the circuit if there is any change in the conditions in the circuit. In that way, you are getting the status. And we are trying to pass it to the RTUs like that, remote terminal units, the status everything. So pulse signals also we are using. So these are the periodic informations will be acquired from the field. So these are includes energy data, rainfall, like that. So if you could see typically, for example, how the flow of data could be there, passing from the field devices to the SCADA control center. You can see here how we are trying to, suppose bus bar voltage, we want to get the measurement. So we are using the potential transformer. So in that way, the data will be passed to the potential transformers. 110 volt it will convert from the high voltage. So from that again it will goes to the voltage transducer, where we are using this. If you are using 4 to 20 milliamperes, you can use like another type of sensors also we are using directly converted into digital and passing to the like that, or through this current loop 4 to 20 milliamperes if you are using. So that analog signal, whatever the current measurement through a long distance you are trying to measure, so converted, and it will be converted into data packets. So under using particular protocols, communication protocols, through the channel will be passed the data. So where field communication front end, those will receive this data and pass on to the control room like that. So there you can see the servers, everything. So a particular data will pass it to particular servers. Those things also we can see. So this is the typical thing where how a bus bar voltage and how you are mimicking the SCADA center that voltage state measurement. So these are the various functions of substation aspects. If you see automation control, we are selecting and opening, closing circuit breakers and disconnectors, blocking and unblocking also will be used here. Suppose in the particular circuit breaker, suppose low gas pressure is there, and we should not give initiation of that to control that. So we have to block it so that necessary action will be taken. So those things and all will be properly done with the blocking and unblocking commands also before going to action, passing into that state. So in that way, your information to the circuit breakers will be passed with very secured way of opening and closing actions. So you can see monitoring aspects, position indication, open, closed circuit breakers, disconnectors, acquiring and process data from power transformers, and various data related with that also we can get in the substations, like dissolved gas analysis, partial discharges from the measurements, and moisture measurement. So like that, various data we can get and can be analyzed. And also you are displaying substation events in the substation control room. All the actions, what is happening, everything. So you can see monitoring aspect. So these are the displays that will be there in the closed position, some light and open positions. So if there is any circuit breaker tripped by a protective relay, so flashing lights like that. So those type of displays will be easily understood and necessary actions will be taken. So information concerning the feeders, switch gear, auxiliary power system, related signal, change of status, measurements, voltages, currents, power, temperature measurements. So monitoring aspects in these event date and time of event stampings, all those informations, and appropriately alarms, everything can be given appropriate times. Alarm annunciation. So if there is any power transform protection relay activated, overloads or overrun of circuit breakers mechanisms, loss of voltage, failure of communication links. So alarming also can be given. And also depends on there are different techniques also, suppression techniques in the alarm, whichever is important and in what way, depending on the application aspects also, we can use these alarming techniques. So voltage regulation aspects, changing the position of the tap changer of power transformers, appropriate time. So you can see from these SCADA, you can collect the data from the field, convert the data into transmittable form, and bundle the data into packets, transmit the packets over the communication media, receive the data at the control centers. So and decode the data, display the data. So in that way, communications, different communications we are using, and media we are using, like through the power line communication or through the satellite communication, or very high frequency radio frequency communications, like that we are using, and passing into the station master stations. So there we are using the different communication protocol standards. Suppose very critical data for protection, everything appropriate control should be done. So particular communication can be taken, which will get within very faster rate, or some data will be there. You may not require at very faster rate. Those data can be sent to that other communication. So in that way, cost aspects, everything can be optimized. So you can see field equipment. So RTUs nowadays at very high voltages aspects substations, IEDs are preferred. So where from the IED monitoring control as well as protection aspects and all, using the multifunction relays, we can use from the IEDs and pass it to the data concentrator and master stations as well. So if you could see RTUs, remote terminal units. So in olden days, RTU was as a slave of the master station, but nowadays additional features also they have added in the RTU. So advanced techniques also, they have computational techniques, everything they have added into this RTU for better computations, and passing into the master station so that appropriate actions will be taken. So this RTU collects data from the field devices, processes the data, sends the data to master station through the communication system. At the same time, these RTU remote terminal units receives the control commands from the master stations and and it will tries to control these to the field devices. So like that, both things will be happening from through the RTUs. So these what in the RTUs different aspects they have advances they have made in 1921. If you see, automatically detect a change of status at a remote station and report the change to the control center, like that features and all added from that onwards. And also other features they have added, check before operate. So it's an important thing. Before operating, you check and act upon that. So logging of the data from that supervisory systems are evolved, where appropriate protection features and all added. In 1980s, based are incorporated in the remote terminal units. So so these are the communication subsystems in the RTU. So these RTU also sends an appropriate message to the master station for completion of the task. Also collects the data from the field and process conveys relevant data to the master station, and it reports to the single master or multiple masters like that. So logic subsystems, mainly database and also major processing, timekeeping, control sensing, everything will be done in the logic subsystems. Even logic subsystems, analog to digital conversions, computations also will be done. So these are the termination subsystems with respect to the communication lines connected, substation devices connections, power supplies, and even you can see the human machine interfaces displays everything, indications, everything. If anything problems are there, that indications also will be done. So these are the communications actions that will be taken there. Suppose messages from the master stations received interpreted by the communication subsystem. Required action is initiated within the RTU, and it will initiate the control action in the field. So in that way, all the communications will be done appropriate timings. So even communication subsystem receives the data from the field, processes the data, bundles the relevant data in appropriate protocols, conveys to the master station. So there we will see the communication protocols, how we are using, and in that way, this will be data and particular data, whichever is important, that will be transferred. So all the things will be done in the message security, in the RTUs itself. Parity checking, cyclic redundancy checkings will be done in the SCADA communications also. So these cyclic redundancy checkings will be done in appropriate way, adding to the main block of the data. So multi-port communications they are using. So these are timekeeping, our control as actions, everything can be done with these logic subsystems of RTU. So timekeeping sequence of events, like different data sequencing, everything will be done. So even 8 milliseconds resolution also can be done very fast. Data acquisition processing also will be done. So you can see data come in analog and digital forms as well, and it will be processed. So digital data acquisitions, current status, sequence of events, accumulation of the values, like that. So these are the pulse events. So these are the termination subsystems where any surges, lightning, or voltages will be taken care. So these are the digital terminations where suppose the optical isolators are connected and it provides the good isolations. These are the analog terminations, like the different terminations will be there. Human machine interfaces. So these are particular RTUs. So you can see while opening the circuit of the circuit breaker, everything, all these interlocking condition, blocking condition, in that way, appropriate control command will be issued. Like that, all the things will be taken care. So synchronization checkings, opening the coil, closing the coil. So in the magnitude, frequency, phase angle, everything will be checked. So you can see in the interlocking conditions, circuit breaker will not close if any associate disconnector is in transit condition. So like this, all things will be monitored. Suppose a disconnector shall not open if associated circuit breaker is in closed position. checking of blocking conditions. Suppose if there is any low pressure in the circuit breaker aspects, pneumatic effective is there. So those things will be blocked and appropriate actions will be taken. So alarm managements, everything will be done. So even from the IEDs, protections will be done. So these are the HMI, substation HMI. All in the displays everything, single line diagram showing the switchgear status, measured values, control dialog with interlocking and blocking details. Everything will be given appropriate time. So even event listing, position changes, nothing device, all different substation, everything will be monitored at the master stations. So all this will be displayed and appropriate actions will be taken and reporting. So this is the evolution of these IEDs. So electromechanical mechanical relays to digital. So if you could see the different classical, conventional and digital substations. So there are different ways of changes are there and different layers you can see. You can see classical serial communications were there with a faster rate, Ethernet communications are there. Still in the digital nowadays, process bus with the standard 61850 standards they are using through the process bus IEC 61850. So in that way, very fast actions they are taking. So you can see the different layers, even optical fibers and all they are using, and so that effectively without noise, everything you are going to take appropriate actions also. So through these IEDs, you're going to get overcurrent, under voltage differential, those protections. Even circuit breaker isolated status monitoring, everything can be done. So these are the different communications where it can do through the process bus communications, IEC 103 and DNP3 protocols, synchro phasor measurement, PMU measurements. Features also will be given added in these IEDs. Time synchronizations, these are different ways they are using. So these are the different, you can see typical IED of particular company, how they are using their products for a particular series control and monitoring they are using for a particular series transformer, reactor protection, line impedance protection, bus power protection. These are the machine interfaces, human machine interfaces you can see. So these are the power supplies. So even if there is any problem with one particular IED, and it can be communicated to other IEDs also, like that features also will be there. In that way, effectively communication will be passed to the master station where particular IEDs some problem occurred in that. So like that also will be passed to the other IEDs. Some features will be added into that. Suppose these transformer input modules connected. So binary input modules. So can you see the optocouplers they are using and trying to get the data. So these are the binary input modules and typical IEDs. Likewise, binary output modules will be sent. So various output modules appropriately sending the control actions, everything. So even some provisions will be there, like some of the other type of signals we want to get. Those things also will be available. So milliampere input modules like that. So there were different ways in which communication will be done appropriately. Time synchronization module will be there. Galvanic RS485 communication modules will be available. So you can see whole functional blocks. So basically, with the programming and all different features of relaying operations can be done. That feature will be used in these IEDs, where it can be used for the as a multifunctional relays. So that is a main advantage if you go for these IEDs. So all different features we can have, even event recording, fault recordings, monitoring, protection, control, those some of the features we can add with this. So through these intelligent devices, we can see monitoring aspect, control, as well as since it is having multifunctional relays with the feature, you can have the protection, and even it is having PMU features, pressure measurement unit features also through GPS time synchronization also it can be done. So in that way, these IEDs nowadays they're trying to use in the particular expansion of the substations where the higher voltage levels also these IEDs they are preferring very well. So you can see structure. So protection functions, control functions, programming logic. So with the software we can do all these ways and process that. Suppose we are monitoring some voltage, so trying to get the voltage. So if it is, we can set the different settings, like if it is reaching to the particular value, so do the particular action, tripping action, like that. We can give all this with the software features, everything. With the programming itself, we can do all this. So real-time clock, disturbance event, any disturbance that also will be recorded. Communication functions, different as I told, different communication features. So likewise, you can see trip and alarm contacts, digital inputs, LED, serial, analog inputs, like that you can get and it does the processing. So these are typical IED communications. So different communication interfaces it can have like Modbus, DNP, IEC 61850 through process bus. So you can see main advanced functionalities. If you see, you can have production function including phasor estimations. So these were the modern numerical layers. Everything will have these features with Matt Claren. He has proposed the concept of open system realm where with the same hardware, by modifying the microprocessor programming algorithms, everything, you can have the different features. Isolation, analog signal scaling will be there. Anti-aliasing filters will be there. There's an estimation, relay algorithm, trip logic we can do. In that way, multifunction relay can be happen. Even program logic breaker controls without PLCs, it will have its own control. So in that way, externally, uh, uh, you no need program logic controllers. So this itself, this IED will handle the logic inputs and outputs of the protection functions. These are connected internally with flip-flops or gates. So in that way, it will eliminates the use of external programmable logic controls. It will does all this process. So that's where it will have the functionalities. Even metering and power quality analysis also they are using. Self-monitoring, external circuit monitoring, event reporting under fault conditions. So you can see there is a migration from RT to IDs, from that again data concentrator, again to merging units. There is a different changes with respect to the speed that with that particular protocols and all. These changes were made. So typically with these sensors and field devices, RT util going. So from there IEDs. So again data concentrator and connected directly to the substations, like that they have used. Now through the process bus also, merging units where it will converted into the all the data will converted into the digital data, and straight away it will process to the station bus through process bus, like that also they are doing communications. So even protection and all you want to do. So to this process bus connected to IDs like this, appropriate actions will be, control actions will be given. So not only control, but it will have a feature of protection. So in that way, there is a more advances in this. So even fault diagnosis also will be there in that. So in the typical master station, you can see computer server systems. Like SCADA server for all SCADA functions, data collection, display, control command from the master stations. It will does that particular computer server. So likewise, different application servers you are having. So as well as information storage and retrieval, historical information management servers will be there. So like that, different servers will take up appropriate things into account. So all recording, retrieval, report generation, everything will be done in these uh, ISR HIM. Like development servers also there. Suppose any changes or developments day-to-day running of the system. So there they are using these uh, development servers. Suppose any display development, database generations will be done through these development servers, network management servers. So control centers, suppose they are having many digital devices connected via local area networks. So those management servers will do all these things. So like that, CFE communication front end, those are all with the peripheral devices. Suppose using the slow serial interfaces connecting to the communication networks like that, or FEPs, front end processors using a high speed parallel interfaces. They are used like that, communication controllers. Even we are using ICCP, intercontrol center communication protocols that supports the data transmission support between master and hierarchies. Those things it will does. Suppose ICCP server, suppose at a regional load dispatch center, will exchange data between this RLDC and National Load Dispatch Centers, NLDC. So in that way, along with the state load dispatch centers also. So in that way, it is inter-control center protocols supporting. So even we can see communications, small master stations. We can see depend upon the applications. We can see use these different types masters stations, medium master stations. So you can have a LAN router hierarchy. You can use different servers in medium master stations. Suppose ISR servers, ICCP servers, network management sensor servers. So this is a large master stations where all typically load dispatch centers and all when they are using. So those things can be used very effectively. So you can see time and frequency from GPS in the routers, CCP communication servers. So typically there are different alarm suppression techniques also they are using with respect to the area aspects, alarm filtering they will use, whichever is critical, and priority points. and timed aspects, knowledge based also they are using. So these are the different type of master single RTUs, simple uh, way of communications. Suppose a single master to multiple RTUs. So this is a multiple masters, multiple RTU like this. So national load dispatch centers, regionally load dispatch centers like that. So with respect to those things, it will depends. State level, distribution level, plant level, station level. So you can see timings also how it will goes. So different communication topologies also there, point to point, multi drop point. Suppose the time sharing and all, and spatial sharings and all can be done with these. And also, if we are having more links, means we can go for the topologies like bus topologies, rings topologies, start topologies, mesh topologies, type of communications they will go. So suppose a ring topology. So all will be there in the loop. Even main master station also will be there. So each is having its own merits and demerits. So these start topologies. So there will be a central hub which will control all. So likewise, the data communication tech, master slave, peer-to-peer, multi-peer. So its own different will have its own advantages and applications as well. So these are the different data communications. Like in the communication system, you should have message to pass on that, and sender information, receiver while receiving where to are receiving address or like that, or what type of medium you are using for the message to travel, coaxial cable, fiber optic, microwaves, radio waves, like that, different mediums through which it is passed, protocols. So it is a set of rules that governs the communications, and with the data communication with the two devices, how it is done. So how you have communicated and when it is communicated, all these things will be there. So these are the error detection techniques also will be done. So there are different media access control techniques they are using for receiving the data and how you can take the data. Like polling techniques are there, polling by exception is there, token passing techniques are there. Even uh, uh, if there is any possible of different things are coming at the time, there is a possible of collision, that collision sensing and collision detection, like that features also there. So you can see in the while sending the data from one devices to another devices, so how it is done, like through the different layers it is done. So physical layer first it will be there, data link layer, next stage, next network layer will be there. Everything will be keep on adding, and at last the data will be sent to that master station. Again it will be taken out all these things and main data will be received. So in that way, these layers will be used. Even you can see in the presentation layer, it will have the feature of encrypt, compress data. Like if there is any protection security you need for the data, you can use such type of protocols where you are having this encryption or decryption, compressing of the data, like that. So it depends on the different protocols that you are using and what type of in that for your application you can use that. So these are, you can see device one how it is, from the device to one, how it will be. You are constructing from the physical data, network, what type of network communication, transporting, and presentation application. Again, you are trying to redact everything, and you are getting the actual data, physical data, like that. So in that way, message will be sent. So there are different protocols we are using, Modbus type of communication protocols, IEC 60870, telecontrol equipments type of protocols we are using. So even you can see a companion standard in that communication, IEC 60870. So T101, T102, T103. So this telecontrol, suppose 101, 103, master slave communication. So particular bus topology, cyclic polling techniques, different things it will does. Likewise, another, suppose if you see 101 station initiation, data acquisition, cyclic transmission, 103 handles the protection functions, circuit breaker, type of fault, trip signals. So in that way, in the protocols it will be added, how it can be performed. It can be taken care of network version, like that. So another type of protocol, distributed network protocols for particular applications, and in particular some of the regions in the countries, they are using such type of protocols. Some other protocols they will use, like that. So even intercontrol center protocols are also there, particularly regional national control centers, communications, everything protocols, standards will be used, Ethernet. So where it will have CSMA CD for media access control, physical and data layers it will consist of, even TCP IP. So some of the layers it will be having in the 7 layers, some of the layers, like that, some add-on features will be done. So IEC 61850, typically in the modern digital substations, they are trying to use these such standards. IEC 61850, they are implementing. So whole substation they are making. Some of the where you can they are implementing where whole substation is digital. So with these protocols, they are using IEC standards. So you can use some of the, all these things will be converted into the digital and pass on to the master stations, like that. Very fast, critical, everything can be done using this process bus through this IEC standard 61850. So even time synchronization, everything can be done. So as per these standards of protocols. So you can see all distant substations, process bus they are using, brake control, protection relays, appropriate protections they are using. Even phasor data, they will do. They can use it for appropriate actions like that through the phasor measurement units. So you can see here typically the advancements you can see without SCADA, just within that RTU. If you could see hybrid IEC 61850, so how they are using. So you can see fully digital substation architectures, how it is. So they are using say IEC 61850 process bus and replacing existing ID. So fully substation. Here in the hybrid, they are using add IEC IEDs. They are using add Ethernet bus, process bus, like that. So the different typical protection hardware, how they are using for the control local area networks via through LAN. Nowadays they are implementing these aspects and all. So even production via messaging, the process bus communication protocols, how they are used. So in that way, very faster way they will do go for the protections aspects. Even any problems occurred, how effectively they are doing using these latest techniques of these protocols. So these are the references. Thank you. Thank you, one and all.
Sir, thank you so much, sir, for your brief lecture on SCADA.
Yes, sir. Thank you. Thank you very much.
Thank you, sir. Thank you for your wonderful presentation, sir. Participants, if you have any queries, you may ask our expert.
Thank you, sir.
Thank you. Thank you very much.
No one has any query, we may wind up the session today. We will start the session tomorrow at 6 p.m. Rangashankaran, sir?
Yes, ma'am.
Yes.
Yes,
Sir,
ma'am.
thank you, sir. Giridhar, sir.
Okay. Thank you very
So
much,
sir.
opportunity to deliver the lecture. Thank you, one and all.
Thank you so much, sir. Thank you so much for your wonderful lecture, sir. Participants, so this is there comes the end for the day one of session 2 and day 1 of this first day of 6 days FTP. Thank you to all the participants. So good night from the coordinator side. We'll meet you and catch you up on tomorrow evening sharply by 6 p.m. for the third session of day 2. Thank you, one and all.